Hello everyone. Today we will work out this new exercise in trigonometry. Let x be a real number. Prove that for all n greater or equal to 1, n a positive integer, tangent of n plus 1 times x over 2 is equal to the sum of sine kx for k equal to 1 up to n over sum for k equals to 1 up to n of cosine kx. You can pause the video and try to solve the problem for yourselves, and then come back for our solution. Now let's start what we need. So we'll need first the sum of a power series x to the k equals 0 to n. Well, let's say k equals 1 to n, just for convenience. So the sum from k equals 1 to n of x to the k, that's equal to x times x to the k minus 1 over x minus 1. But that is true for x, of course, different of 1. Another thing is the Euler formula. So a to the I x, for x of course real number, is equal to cosine x plus I sine x. Of course, that gives us exponential of minus ix is equal to cosine x minus I sine x. And that will yield also this formula that we need, which is exponential ix minus exponential of minus ix is equal to I times sine of x. That's also an important formula in our solution. Now let's start to solve this problem. We can start from the left or from the right, but what we will do is to start from the right. So let's name the sums. A sub n is the sum of cosine kx from k equals 1 to k equals n, and bn the sum for k equal 1 to n of sine kx. an plus I times bn is equal to sum of cosine kx plus I sum of sine kx. For k starting from 1 to n, both sums. Since we have the same number of elements, so we can gather the elements of the sum under one single sum. And so these two sums are equal to the sum from k equals 1 to n, and that is sum for k equals 1 to n of e to the I kx. But e to the ik is equal to the sum from k equals 1 to n of eix e to the ix all to the k. Good. Now this sum itself is the same as this, with x here equals to e to the ix. So the sum is equal to e to the ix times e to the ix to the power n. Well, that's n here, minus 1 over e to the ix minus 1, which is equal to e to the ix times e to the inx minus 1 over e to the ix minus 1. Now, to make use of this formula here, we will factor e to the inx over 2. So e to the inx over 2. And so we have e to the inx over 2 minus e to the minus inx over 2. The same here, we will factor e to the ix over 2. And we have e to the ix over 2 minus e to the minus ix over 2. And so we have e to the sum of these two powers minus the power down. So it's the exponent down. Ix plus nx over 2 minus x over 2 times, so here we have 2I times sine nx over 2 over 2I here, 2I sine x over 2, using this same formula here. So of course these two here cancel, 2I and 2I, and so we're left with, if we do this sum here, it's e to the I times n plus 1 x over 2 times sine nx over 2 over sine x over 2. Now, we're using, for this exponential here, we reuse the same Euler formula. So this is equal to, we'll start with this one, sine nx over 2 over sine x over 2 times cosine n plus 1 times x over 2 plus I sine n plus 1 x over 2. If we expand this product, we'll have the end sine nx over 2 times cosine n plus 1 x over 2 over sine x over 2 plus I times, again, sine nx over 2 sine n plus 1 x over 2 over sine x over 2. Nice. Let's not forget this is an plus I bn. We conclude from that equality that an is equal to sine nx over 2 times cosine, that's times, cosine n plus 1 x over 2 over sine x over 2, and bn is equal to sine nx over 2 times sine n plus 1 x over 2 over sine x over 2. Good. Now, hence, bn over an, which is, of course, the sum of sine kx, k starting from 1 to n, over the sum for k1 of kx is equal to bn sine over sine x over 2 cosine these two cancel because they're the same number. That gives us exactly sine n plus 1 x over 2 which is tangent that ends our proof and ends also the video. Thank you very much for watching. Don't forget, please, to subscribe and like and share. Goodbye.